Hello everybody. I thought I would walk through a significantly more complex proof here. I already have it set up. I should probably delete these line numbers here because those are not relevant yet. Um, so all I did so far was I just copied over all the premises because that's the first thing to do, just to sort of save us time on the video. Excuse me if my voice is going hoarse a little bit. I've done several recordings with my speaker off accidentally, so I am redoing this again. Okay, so maybe you're stuck. Suppose you're stuck. So we're trying to prove uh, uh, M or Q is true. We don't see that anywhere around here. Um, so maybe you're not sure where to start yet. Um, one thing you can do is you can simplify a little bit of this. We have this, this line here, and this can be simplified to both Z, therefore T, and T, therefore Z, and that is biconditional elimination on line 1, and it's the same for both of those. And again, some of these might be useless steps you don't need. And if you could see that, that's great, and avoid them, that's fine. But sometimes just getting the ball rolling really helps. Now, one thing you'll notice, if you look at all our premises and all of our simplifications so far, there's nothing else that we can really simplify easily. And we don't have any givens, right? We don't have any given atomic sentences like just S or T or Z or anything like that. The closest thing we have is this disjunction, because we know that one of those must be true. We know that either S is true or T is true or both of them are true. So that might be a big hint there that what we're going to have to use here is disjunction elimination. And so let's just jump into that and see how far we can get. So the way you do disjunction elimination is you do a subproof for each part of the disjunction, and then anything you can conclude from both parts of the disjunction, you can move from your subproof to your main line of proof. Because if it's true, right, if some other thing is true, if either Z is true or S is true, or sorry, if S is true or T is true, then you know that since S or T must be true, that conclusion must be true. And I realize that was a lot of words, might have been hard to parse. So let's just go ahead and try to walk through it. So we'll just assume that S is true. So that'll be an assumption. If you want, you can put in a dividing line. We are now on line 8. And how might we get M or Q from that? Because that's something we want to show. Well, we now have S, right? And we can see that we can get something here from S. We can get Q. And to cite that, you just use modus ponens. You cite line 3, which has the conditional. And then you cite the antecedent, which is on line 7. So it's part of our subproof. And we know that if S is true, Q must be true. Another way to cite that, if you really want, is you can do conditional elimination, and the citation is just the same. That's just another way of doing modus ponens. So whichever one makes the most sense to you. In order to save room, I'm going to only have one of them up here. But you'll find that I use various ones at various times. Okay, line 9. We have Q, but Q isn't enough. We want M or Q. Well, fortunately, since this is a disjunction, that couldn't be simpler. If Q is true, then Q or absolutely anything else is true, right? So if it's true that, George Washington was the first president of the United States, then it's also true that George Washington was the first president of the United States, or Godzilla exists. Because even though Godzilla doesn't exist, I'm not saying Godzilla exists. I'm just saying it's true that either George Washington was the first president of the United States or Godzilla exists. And since George Washington was the first president of the United States, the entire sentence is true. So here we can conclude M or Q, and just one of the simplest rules, disjunction introduction, and we just cite the line 8. And this one sometimes confuses students because they're wondering, how the heck do you get M? But again, with disjunction introduction, you can add whatever you want. I could have concluded, what letter haven't we used? I could have concluded W or Q. It doesn't matter. Or I could have concluded, W or Y or Q, right? So I'm concluding M or Q using disjunction introduction. And now I have one subproof completed, but that's not enough for disjunction elimination. I also have to prove the same thing with t, assuming t is true. So that's my next assumption, and this is my next dividing line. So just put in our line numbers here. Let's get some more lines here. Not sure how many we're going to need. Okay, now we know t is true. What can we get from t? Well, we can get z. So let's just go ahead and do that. If it's a wasted step, then we just have a wasted step. No real harm is done, and you can always clean up your proof a little bit later. Again, this is modus ponens. We use line 6, and we cite the antecedent in line 10, and we have z. Can I do anything with z? Well, this one might be a little bit harder to see. Where do we see z appear? Well, we see z appear here, but it's in the form of not z. And notice that one of the things I want to get is m. If I can get m, I could show that m or q is true by the same reasoning that I can show that m or q is true if I know that q is true. So how might I get m from this? Well, if I have not z, then I can use modus tollens to get not m. So getting not z is very easy. It's just double negation introduction on line 11. Now I can get not m using modus tollens on lines 4 and 12. But I don't want not m, I want m, so I use double negation elimination on line 13. And now that I have m, I can go m or q by disjunction introduction on line 14. And now I have both of my subproofs completed. I have proven that if S is true, M or Q is true, and that if Z is true, then M or Q is true. So M or Q must be true. And this is our most complex rule. It is disjunction elimination, so VE there. And you have to cite three things. First, you cite this disjunction, which is on line 2. Then you cite the subproofs for each part of this disjunction. So there's the first one, lines 7, 8, and 9, so 7 through 9. And then lines 10 through 15. And there you go. That is our completed proof. Don't let this intimidate you. This is one of the more complex ones. This is the most complex rule. And again, with most quizzes and tests, what you're going to have is a bunch of sort of question marks. Oops, that should have said assumption. Sorry, I typed that wrong. Where you're asked to say what's missing, right? Sometimes you will be required to do a complete proof on your own, but most of the questions on the quizzes and tests are going to be in this format, and you got to kind of figure out what's missing. All right, I hope that helped. As always, I invite questions in either the raised hands forum or in email, or to come to me during my office hours in a Zoom meeting, and I will talk to you later.